So hello everyone, welcome to another ML project building series. Today we're gonna be building a credit card fraud detection using machine learning model. So let's begin. Here we are having the steps that we're gonna be follow to build this machine learning model. First, what we have data import. We're gonna import the data set that we are going to predict from that the machine learning model. After that, what we have EDA, also known as exploratory data analysis. It will gonna help us to know the dataset more precisely. After that, if we jump, what we have feature extraction. The reason why I put feature extraction here, because all these data and the values that we have on the dataset, we don't need all those. We maybe need to pre-process maybe, or some of them the columns we need to drop. After the simple EDA process, we will know that which data will gonna be needed more. So then we're gonna do feature extraction. After that, feature extraction, pre-processing comes. Here the pre-processing is optional. If it is needed, that I'll gonna use. If not needed, I won't gonna use. After that, the model building process will come. Here I'll gonna use the model that gonna goes with the categorical data set, like predict 0 1 2 something. After that, what I'll gonna do, I'll gonna go to model comparison. So the reason I am doing the model comparison here, I'll gonna test other categorical data set, other categorical machine learning model using the same data set, and I'll gonna see which the machine learning model have the highest accuracy. So the most highest accuracy that I am getting, I'll gonna pick that model and I'll gonna predict using that one. So after that, what we have the prediction. So here I have the outcome prediction that I'm gonna predict using our machine learning model. Here, if the result come as 1, it means the transaction is fraud. But if it is coming as 0, we know that we can decide that the transaction is legit. So after that, what we have the ML model comparison. For ML model comparison, I will be using all categorical data set, categorical machine learning models that only we using for the categorical data set. First, we have the logistic regression, and we have a decision tree. After, we have KNN, also known as k nearest neighbors. After that, we have a support vector machine, and on the last two comes all those are boosting techniques like XGBoost or gradient boosting machines like GBMS. So after using all those, we will gonna compare which model we are getting the highest accuracy. Using that highest accuracy model, we will gonna start the prediction. So now let's jump into our Jupyter notebook. So to build this model, we're gonna use those steps like data import, EDA, feature extraction, model building, and model comparison. So let's jump into our Jupyter notebook. What I did here, I imported all the libraries, like all the libraries that is needed to build this machine learning model. First one, NumPy coming, pandas is also coming, and from sklearn model selection, I imported the train, test, and split. And from sklearn linear model, I imported logistic regression. Here for model building, I'm gonna use the logistic regression as it is a categorical dataset. And after that, from sklearn matrix, I imported the accuracy score. The reason I need a accuracy score because I need to measure the accuracy of the machine learning model and check whether the accuracy score is good enough or not. And after that, what I did over here, I simply imported using pd.read_csv function. I imported the data set. So let's run it over here. And after that, what I'm gonna do, I'm gonna call the data.head and have a look on it. Here what we are having, first 5 rows are coming and all the columns are also coming. And as you can see, all columns have a numerical form. Here it is written as v1, v2, v3, v4. So what in the data set is we have that all are in numerical form. It is not that little bit not that much understandable, because the author of the data set or the owner of the data set, what he or she did, he just converted all those data into using PCA dimensionality reduction process. He converted those data into these types of form, so that the real data of the credit card is not visible. because all those data are sensitive and is not the data like to make on public. So what I can do over here, I can start the EDA process. So for EDA process, what we can get over here means we can simply call data.info. Using data.info function, what we are having over here, we have 284,000 rows are there, and the data types is mainly classified into two forms like floating number and integer number, and all the columns are written over here as you can see, and it also written no values are none, like non-null values. So let's once check deeply is there any null value or not. If any null value contain, we need to remove that one. So I'm gonna use the isNA function. So after isNA function is used, we can see the first 5 rows and last 5 rows is coming. All values are coming as false. So for first 5 rows and last 5 rows, there is no null value. So after that, what we can do, we can call the sum function. After calling the sum function, all the values are coming as 0 0 0 0. For all the individual column, we can tell that there is no value, there is no null value on the columns, oh sorry, over the column. So what I can do next, I can simply call another sum function over here. The answer is coming as 0, so in total there is no null value over here. Now we can check the data class column, because for here we are predicting this column, this class column, like it is mainly initialized as 0 to 1. So what we can do here, I will call data and I will call class over here. So as you see, all values are coming. What we can do over here, I will use value count underscore counts. If we use value, after using value underscore counts, we can see that the data is mainly classified into two numbers like 0 and 1. And for 0, we are getting 284,000 something, and for 1 we are getting only 492. As this data is coming like this form, you can see that the data is unbalanced, like all most of the data like 0 it is coming here. 0 means the credit card is not fake, and 1 means the credit card is fake also. We can call it as a fraud transaction, or this one is not fraud, this one is legit. So as you can see over this data set, most of the transaction data values are coming as 0, which means real or legit, but for 1 it is coming only 492. It is a little bit unbalanced data set, we can say that, like unbalanced data set. So what we can do over here, we need to convert it to balance data set. So to convert this as balanced data set, we simply gonna sample 492 similar to 492 values from here, from these large values. So what we can do right now, we can get legit and use the data, and here what we can do over here, we can use like a class or something. So let me define one thing, like 0 here means that it is a normal transition. Sorry, okay, this is a normal value, and let's tell this one is fraud. We can declare it as fraud. So what I'm gonna do over here, I'm gonna use data, and after that I'm gonna call data dot class column over here, and if the class is equal to 0, then it will gonna be legit, and if it is I'm gonna pick fraud and use the data, same thing will come over here. I'm gonna pick data and use the class column, and if it is equal to 1 coming, then it is fraud. So what I'll gonna do, I'll simply gonna run it and I'll gonna print it down. What I can have a legit. I can simply have a look over it. And what you can do over here, you can simply check its shape is coming as the same thing. Now what we can do after that, we can check the like data describe over here, because we need to simply check what is the main difference it's coming. So I'll pick the fraud one also. Hmm, let's check the amount over here. So what I can do over here, I'll pick amount dot, yeah, for amount column is coming over here. Same thing, I'm gonna do it over here also. So as you can see, we are plotting the describe for only amount column only. So after that, what you can see the main difference over here that is coming, like we can see most of the difference are coming as same, like not that same, like mostly same, but there is a difference mostly coming on mean. It is coming here 88 something and 122 also coming, though that's a little bit difference. The reason why we are checking this mean value, because we need to check after the sample that the data is properly sampled or not. If the data is not properly sampled, we need to work on that before feeding onto our machine learning model. So what we can do over here, we can check our data, and over data I will use over group by over here, group by function over here, and I will use the class column. Sorry. And using the class column, I will pick the mean value. If I check the mean value over here, it is coming like on serial wise. So for all the columns, means are coming. Now what we can do over here, we can start the undersampling. And what I can do over here, I can use number of sampling. I'll gonna pick the number of sampling as 492. 492 numbers I will pick. 492. Okay, so let's start. So for new data set, what we're gonna do over here, for new sampling data set, we're gonna use new underscore data, and for this data I'm gonna, what I can do over here, that it will come after, it will come later. That's why I'm gonna pick a legit sample. And for legit sample, what I can do, I can use the legit, and I can use the sample function, and for n I can feed into 492 values over here. Let's print it down and check legit sample, it is working or not. Let's check. Yeah, if we check the shape over here, 492 values only came here. So what we need to do, we need to merge this, sorry, we need to make a new data set with this sample data. So what I'm gonna do here, I'm gonna use concatenating technique. I'll concat this sample to our previous sample over here, like that is coming. I think yes, this one, like one, which is fraud. So what I'm gonna do over here, I can use new data, and for new data, what I can do here, I can call the pd concat function, and after that I will feed the legit sample, and after the feeding legit sample here, I'm gonna use also the fraud column also. Okay, I think everything is okay over here. Okay, we need to simply do another more step, that is We need to define a axis over here. I'm gonna use axis as 0. So let's check once. I'm gonna use new underscore data, and I'm gonna pick the head function. Yeah, as you can see that our data is now plotted over here, the new data that is coming. But I can check over here, I can check like new data shape. I'll check the shape over here. Okay, it is coming as 984. It should not come like this one, it should kind of come only 492. Let me check once. Okay, sorry, this one is okay, because okay, let's check new data dot shape again. So here after checking, we have 984 rows and 31 columns over here, and within that we are getting as you can see, we are getting 492 columns over here for legit and 492 columns for the fraud section. Sorry, 492 rows for the legit and 492 rows for the so let's check for our new data. Let's check the shape again. So what we are having over here, 984 rows over here and 31 columns over here. Columns are essentially same, as because we are using axis as 0. We are targeting our rows. For rows, 492 rows are for legit and 492 rows are for fraud. So what I think our data sampling is done. Let's check its mean value once. We're gonna use a new data over here, and I can use group by function, and using group by function I will pick a class over here that we will gonna doing the prediction, and I will gonna pick the mean value over here. As we compare to our previous mean, let's pick it up and simply paste it over here. We can see that all values are coming as nearby. It is not coming like a high or low or something, or anything big difference over here. As you can see from the mean values, no such big difference over here. From that sample data, we can tell that our sampling is successfully done. If the data had that much big difference, we can tell that our sampling is not okay. We had to work with that sample data before fitting onto our machine learning model. So what I can do right now, I'll split the data set, split the new data set. So for splitting this new data set, I'm gonna use x. For x, I can use new data as I defined before, and as we told earlier, sorry, I'm gonna use drop, and I'm gonna drop the class over here, and I'm gonna use axis as 1, as we are targeting the columns. All the columns will be coming over here without this class column, this one. So what I can do after that, I'll pick y, and for y I'm gonna use new data, and what I can do over here, I'm gonna simply pick the class column only, as we are predicting this one. So let's run it. Okay, there is an error, the columns, okay, I wrote wrong. It will be okay, see, okay, it's yeah, now it's okay. So let's print it. As you can see, without class everything is coming, and for y I think only class, yes, only class column is coming over here, which is defined as 0 and 1. So what we can do on the next step over here, we can simply do the train test split, train test and split the data set. So for training, testing and split the data set, what I can do over here, I'll use the x train as we did on our previous video also. I'm gonna pick up X test, and I can also pick up Y train, and I can also pick Y test. So for here, what I can do, as I simply imported the train test from model selection over here, and simply copy it, and I can paste it over here. And after that, what I can do, we need to initialize, like we are getting X and Y over here as test size. I'm gonna pick up 0.2, and for stratify, I'm gonna use Y over here, and for random state underscore state, I'm gonna pick 2 over here. We can also pick 1 or 3, but I'll pick 2 over here. Same thing. Let's run it. So let's check once, like print X train dot shape and X test dot shape over here. So as we are printing, we can check the data is divided into two forms. It's showing. Now what we can do over here, let's start building the model. Over here, I'll use this model, logistic regression, as we imported this earlier from the library linear model SQL and the dot linear model. So let's use this one and call its function. After that, what you can do, you can call model.fit function, and inside model.fit function, we're gonna feed X train and Y train. So yeah, it is running. So what we can do right now, we'll do model evaluation. Okay, so let's check once. We can also measure our accuracy score over here. Measure the accuracy score. So what I'll do here, I'll now use X train prediction, and for this prediction, I'm gonna use the model dot predict function, and I'm gonna give X train over here. I'm gonna predict on the X train, and after that, if I want to measure the accuracy, I'm gonna use ACC, and for here I simply imported previously accuracy score. I'm gonna simply use that one, paste it over here, and I'm gonna feed over here X train prediction, and simply I'm gonna use Y train over here. So here I think it's done. Let's run it. So what I can do over here, I can print this accuracy of the model. What I can do here, I will call the accuracy also I defined as ACC. Let's run it. As you can see, our accuracy coming a little bit high, but which is 0.9377, which means 93.77% the accuracy value is coming, which is perfectly, I think, which is enough to predict our model. So let's check over here the steps. So model building process is done. Now let's jump into our model comparison. So for model comparison, I will be using some other categorical machine learning model that is used to predict the categorical dataset. So let's do it. So let's jump into our Jupyter notebook again. Here, what I did for model comparison, I simply imported all the libraries that is needed for the next step, and I simply splitted the dataset again. This step is not needed, and after that, what we can do over a random state I defined over here is 42. That is the overall change. So after that, for defining the model, I am taking the models, all the models, and calling the models as into the single row. So what I am doing over here, I am taking the max iteration over 1000 for logistic regression. and I am taking decision tree, random forest, support vector machine. For all of the models, I am calling all those functions, and after that I need to train the model and calculate the accuracy over here. I am taking a blank score over here, and for I am using the for loop for names and model. For each model dot items, I am using the model dot fit function over here, and feeding the extend and widen as we previously did uh, as we previously did. And what I can do over here, after that what I did, I used the prediction and I used dot predict function and use the x test, and taking all those score into name, and I am taking the accuracy score and using y test and predictions. And after that what I am doing over here, I am doing a plot comparison. I am defining a figure over here and using bar plot for all the score keys and values I am plotting. And the color, I am using some different random colors like blue, green, orange, red. And x label, y label is there, title is also there. And after that what I am doing over here, I am adding the accuracy on the bars, like this one is showing like that 0.93, 0.88. So for that I am using the for loop, and for each of the text I am plotting that over the bar that is getting dot get height. And using that one I am plotting this one as a plt dot show function. And after that our model comparison is done over here. As you can see, random forest is coming as the highest accuracy, and logistic regression is also coming as 0.92%. Remember, I did some change over here. Random instead I have used 42. Before that maybe I have used only 2 as random forest, sorry, random state. Let me check once. Yeah, random state I have used 2, and for here I am using random state 42. So for this random state I am getting that all those accuracy. For support vector classifier, it came low. The most lowest is SB support vector classifier, and the highest is coming is random forest over here, and all others is coming pretty good accuracy without this KNN also. So here our model comparison is also done. So I think for today all those step is done, like from data import to model comparison. So that is for today. Thank you for being for such a long time.